Hi guys, let's work the problems on lesson 4.4 and hopefully this will be helpful to you. In the first question it says, are the two lines parallel, perpendicular, or neither? So we can kind of eyeball this. Let's see. The first one is perpendicular. See how they cross at right angles? The second one, neither. It's not right angles. The next one, neither. You can see that they're going to cross if you extend them. Parallel lines never cross, and those are definitely not perpendicular. And the final ones look pretty parallel to me. All right, next. Consider the line y equals negative 2/5 x plus 7. What is the slope of the line parallel to this? That's the easy one. You need to know that this is y equals mx plus b, and that negative 2/5 is the slope. And so we're going to type negative 2/5 for the slope because it's going to be the same. Parallel slopes are the same. Now perpendicular, we're going to go opposite. That means our new one is going to be positive, and then we're going to flip it over and say 5/2 to do reciprocal. Perpendicular lines have opposite reciprocal slope. In number 3 it says consider the line 8x minus 2y equals 3. That happens to be standard form. It says what is the slope of the line parallel and what is the slope of the line perpendicular? So we need to find out what the slope is. Standard form is not super handy, but we can easily change it around into y equals mx plus b so that we can see the slope more easily. So we want the y to stay there, but we need the x to go to the other side. So I have negative 2y equals negative 8x plus 3. And then I need to get rid of this negative 2. It's kind of tricky, so watch carefully. Whenever I divide, I have to divide every piece of the equation. Sometimes I would just draw a line into the whole thing and put a negative 2 down there, but I need you to know that the negative 2 is going to end up going underneath each separate piece. Plus signs and minus signs separate pieces. If it's all multiplication, then it can just be divided by once. But if you have adding and subtracting, each piece that is added or subtracted is going to need to have that negative 2. So let's clean this up a little bit. Y equals negative 8 divided by negative 2 is positive 4x plus negative 3/2. That's the y-intercept. It's not going to be important to us. 4 is the slope of the line. And so I'm going to go back here. Since 4 is the slope of that line, as long as I did that right, the parallel slope will be the same. And the opposite will be negative. The reciprocal will be 1/4, because we could have said 4/1, and then we turn that upside down. So the tricky part of that is just rearranging it to see what the slope is. In number 4, I have the equations of 3 lines, and it says for each pair of lines, determine whether they are parallel, perpendicular, or neither. So I'm going to need to find out what the slope is of these lines. This is not in any tidy form right here. I need to get y by itself if I want. There's that divide by 3 in every place again. So y is going to equal 4/3 x plus 7/3. So we know the slope of this line is 4/3. Okay, and then I have this equation. I'll give it its own color. 6x plus 8y equals 8. And I'm going to subtract 6x. Have 8y equals negative 6x plus 8. And divide by 8. I get y equals negative 6/8 is going to be negative 3/4 plus x plus 1. The slope of this line then is negative 3/4. Look at that. These two are perpendicular. Can you see opposite reciprocal? Okay, and then this one is nice. Line 3 is already in slope-intercept form, so I can tell you that the slope is 4/3. So it is parallel to the first one. So line 1 and 2, I'm going to say perpendicular. line 1 and 3, I'm going to say parallel, and line 2 and 3, I'm going to say perpendicular. So perpendicular, parallel, perpendicular, perpendicular, parallel, perpendicular. If I didn't mess that up, that should be good. Number 5. Consider the line y equals negative 7x plus 5. By now my brain says that is slope-intercept form. The slope of that line is negative 7. The y-intercept is 5. Find the equation of the line that is parallel to this line and passes through this point. So that line is not going to be important to us except to know that the slope is negative 7. Truly, now I am done with that. Okay, so in the first sentence, when I find the equation of the line that is parallel, I'm going to use that negative 7. So I'm going to say y minus 6 equals negative 7 times x minus a negative 6. And it does not say that I have to put that in a certain form, but I might need to, so I'm just going to simplify that. Negative 7x, this was minus negative, so I actually have plus negative 7 times 6 is negative 42. I would add 6 and get y equals negative 7x minus 36. And so either one of these should be fine. And then that's parallel. To do perpendicular, I'm going to use the same point and just change up the slope. And so I would have y equals, instead of negative 7, I would have positive 1/7 x minus 36. So that's one way of doing that. And it says, note that the Alex graphing calculator may be helpful in checking your answer. If you should graph those two lines, you should find that if you graphed all three, you should have parallel to this one and then perpendicular to this one. And also your other two lines should be parallel or perpendicular to each other. So let's see, negative 7x minus 36. Y equals negative 7x minus 36. If I didn't forget something along the way. And y equals 1/7 x minus 36. Partially correct. Equation of the perpendicular line is incorrect. Okay. Interesting. Let's try this. Y minus 6 equals. We still should have 1/7 if I did the first one right, times x plus 6 and it liked that fine. I'm not quite sure what I typed wrong on that. Y minus 6 equals 1/7 times x plus 6. And so I could have y minus 6 equals 1/7 x plus 6/7. If I add 6 to both sides, I get y equals 1/7 x, and then 6/7 plus 6 would be 42. 6 times 7 is 42. So for some reason, I just had the y-intercept wrong. I had should have had 48 over 7 instead of the other y-intercept. So beware. Whatever you have in the first one, the y-intercept is not going to necessarily be the same in the other one. I made that false assumption in the way I did that. So do them separately so that you don't end up with the wrong y-intercept. All right, I'm going to try another. I can always cut it off if my video is too long. All right, so in this, I have a slope of 2/7. So when I'm working on my equation, let's just put those in point slope form and not have to sweat the slope intercept form. So we're going to say y minus a -3, so plus 3 equals my slope, which is 2/7, times, times x minus a -7, so that'll be plus 7. And then down here, we're going to do the same thing, but we'll use the oops, look at that. They switched parallels on the bottom and perpendiculars up here. So I'm actually going to have to type that same equation and put it down here. I wonder if I can copy it and paste it. Come on. Come on. Well, apparently not easily, so I'm just going to bite the bullet and do it. If you haven't learned that sometimes that needs to just be your resolve to get things done, it's true enough. Sometimes you just have to take a deep breath and persevere, really. Okay, so I accidentally put that one in the wrong place, which is a bummer because I find it a little tedious to type out things. I'm sure you do too. Now, y, we're looking at minus a -3, so we're going to go plus 3 equals, now perpendicular slope is opposite reciprocal, so we're going to go opposite, which happens to be negative. Reciprocal just means 7 over 2. And then we're going to do x minus a -7 is x plus 7. All right, and there we go. Yay. All right, let me know if you have any more problems. Give that your best shot, and then you'll be working on your learning path in ALEX.